Hi everybody, it's Mrs. Dunn, and now that we know how to solve quadratic equations several ways and we know how to find the zeros of quadratic functions, we're going to start to analyze the graphs of quadratic functions. Specifically in this screencast, we're going to identify the difference between vertex form and standard form for a quadratic function. Then we're going to look at the graphs of a quadratic function and identify visually the vertex, the axis of symmetry, the x-intercept, the y-intercept, whether that vertex is a max or a min of the quadratic function. We're going to do that visually, then we're going to do it algebraically. And of course, we're going to look at the graphs of quadratic functions. So what I want to start with is a graph of a quadratic function. So here's the graph of a quadratic function. And what I want to do is I want to go through and identify just graphically all of these pieces. So the first thing is the vertex. So the vertex of the quadratic function is where it stops from being increasing and starts to be decreasing, or if it was upside down, that it was decreasing and then was increasing. So that vertex is right here. Now that vertex is going to have two coordinates. Those coordinates will be an x and a y value. So when we talk about the vertex, typically you're going to see it given these coordinates, h and k. So the h is the x value and the k is the y value. Now, this is a pretty obvious question because you're looking at the graph. But is that vertex a max or a min? Is it the top or the bottom of the graph? Well, obviously it's the top of the graph. So we say that vertex is a maximum. We say the maximum is the y value, which is k, and where it occurs, the x value, which is h. The next thing we want to talk about is that axis of symmetry. You know from previous screencasts that symmetry is all about that. Like think of a fold. If we could fold this graph so that one side would match the other, where would that folded line be? Well, the folded line is going to go right through the vertex. So that's called the axis of symmetry. It's the folded line. If we fold it along this dotted line, the left side is going to match the right side. Now, that's a line. So the equation of the line is x equals h. It's x equals h because it goes through the x part of the vertex. I want you to notice that three things came from this point on the graph. The coordinates of that point are the vertex. You can determine whether it is a max or a min from looking at it. You can also do it from the graph. But that vertex is where you're going to find the max or min, and you're going to find out where it occurs. You also get the axis of symmetry, all from the vertex. Okay, now just looking at the graph, not actually figuring out these numbers, what about the x-intercepts? The x-intercepts is where the graph goes through the x-axis. That's these blue dots. And finally, the y-intercept. The y-intercept is the green dot on the graph. It's where the graph goes through the y-axis. Okay, so that's an overview. Those are all the terms that we want to learn and how they're associated to the graph of a quadratic function. And now what we're going to do is we're going to start looking at equations and connecting the equations to the graphs and figure out all of these actual values. So there are two ways that you will see the equation for a quadratic function written. It could be written in vertex form or standard form. And there are advantages to each of these forms. The first one we're going to talk about is vertex form. Here's an example of an equation that is written in vertex form. What's cool about this is you should remember from previous screencasts that we can do a transformation. We should know what that parent function is. And you should know how this graph is different from the parent function. Think about that. Remember, the parent function is y equals x squared. So how is this graph different? It shifted 4 units to the right. It's vertically stretched by a factor of 3. Remember, that means it's skinny. It's reflected over the x-axis. That's what this negative sign does to the graph. And it's shifted up 6. So I graphed that on the graphing calculator. You can pause this screencast and do that yourself. And you'll see this is the graph of that quadratic function. So now that you have the graph and looking at that equation, we want to identify the vertex. Is it a max or a min, etc. So let's go through each of these. So what about that vertex? The vertex is the very top of this graph. And that's point. Remember, we moved. Here's where the vertex used to be. Remember, we moved to the right 4 and up 6. So the vertex is 4, 6. Let's look at where we get that from the graph. See, it's HK. So notice there's a negative sign here. That means we're taking the opposite. So it's the opposite of -4, +4, and +6. Is it the top or the bottom of the graph? Well, it's the top. So the maximum is the y value of the vertex, which is 6, and it occurs at the x part of the vertex, or the h part, which is 4. Next up is that axis of symmetry. That's the line that goes straight through, the vertical line that goes straight through the vertex. So the axis of symmetry is x equals 4. All right, all 3 of these answers all came from the vertex. Really important step. Next up is the x-intercepts. So the x-intercepts requires a little bit of algebra. So I want to do that on the next screen. So remember, an x-intercept is where this function is equal to 0. So when does f of x equal 0? So in this problem, we're plugging 0 in for f of x. That means the left side of the equation is 0, and we're going to solve this. Because of the way this is written, I'm going to solve this using the square root method. So what I'm going to do is subtract 6 from both sides, then divide by -3, and then I'm going to take the square root of both sides. So x minus 4 is equal to plus or minus the square root of 2. And when I add 4 to both sides, I get x is equal to 4 plus or minus the square root of 2. So the x-intercepts are 4 plus the square root of 2 and 4 minus the square root of 2. Next up is the y-intercept. The y-intercept is where the graph goes through the y-axis. So it's where the graph is when x is equal to 0. So it's the value of f of 0. So we plug 0 into the equation. This is different than the x-intercept. And when we plug 0 into the equation, we get -42. So the y-intercept is -42. And lastly, I want to identify the range of this function. So what are the legal y values that it goes through? So looking at the graph, the y values start at -infinity and end at 6. So the range of the function is from -infinity to 6. All right, did that all make sense? We're going to see. So I've written another equation up here that I'd like you to try. So here's another function written into vertex form, and I want you to find the vertex, the max, min, where it occurs, axis of symmetry, y-intercept, range, and graph. You can skip the x-intercept for this one, but I want you to solve all of these. So pause the screencast and go ahead and find all of those values. All right, welcome back. Did you get -4, -1 for the vertex? Remember, it's the opposite of +4 and -1. It is a minimum. See, This is a positive 2. Since this is positive, my u is facing up. When that a is negative, it's facing down. But this is positive, so it's facing up. So the minimum, and the minimum occurs, is -1. That's the y value, and it occurs at -4. The axis of symmetry should be x equals -4. Plug in 0 for x to find the y-intercept. Hopefully you got 31. And the range goes from the y value here, which is -1, all the way up to infinity. All right, good job. I'm going to stop here. I'll record a second screencast so we can talk about standard form.